Hey, 6th grade. We are going to get started with our first lesson in Module 8, and it is called Understand and Apply Exponents. We are starting on page 234, up at the top where it says Build Understanding. And over here in the right-hand corner, we have a little box where it says Connect to Vocabulary. These are going to be important words from now on in your illustrious math careers. It says, when a number is raised to a power, the number that is used as the factor is the base, and it'll make sense in a minute. An exponent is the number that indicates how many times the base is used as a factor. So we're going to start with this build understanding question, bunch of questions here at the top. So it says, a small company uses a phone tree to notify employees of cancellation due to bad weather. The manager calls 2 people. Then each of those 2 people call 2 more people, and so on. So we first of all need to fill in the rest of this table. So we know that on round 1, when the manager calls her 2 people, boom, there's the number of calls. These 2 people call 2 and 2. Those 2 people call 2 times 2 times 2, and so on. So we just keep multiplying 2 times 2 times 2 times 2, 2 times 2 times 2 times 2 times 2. So far, so good? So what pattern do you see here when you take a look at the table, the calling tree table? When I look at it, I see that, for one thing, it's always multiples of 2, and each time we go down a row, then we're multiplying by another 2. So that's what I would write in these blanks. What pattern do you see, though, when you look at that? Pause the video, write your answer in there. All right, question B. And there's several of them that go with this. Complete each statement to describe the pattern. In the second round of calling, the total number of calls in that round is equal to the product of 2 2s. And we know from all of our years of school and multiplying already that the product is the answer to a multiplication problem. So, when we come down here to the next one, it says, in the third round of calling, the total number of calls in that round is equal to the product of how many 2s? Well, if we come back up here to the third round, it's equal to the product of 1, 2, 3 2s. So we need to write 3 in the blank. In the fourth round of calling, the total number of calls in that round is equal to the product of 1, 2, 3, 4 2s. So we write 4 in that blank. And in the fifth round of calling, the total number of calls in that round is equal to the product of 1, 2, 3, 4, 5 2s. It means we're going to multiply 2 times 2 times 2 5 times. All right, and then for question C, it asks, how is the number of the round of calling related to the number of times 2 is used as a factor? Ooh, okay, this is another one of those. You are going to have to answer, pause and answer on your own. Now, when I look at the calling table, I can see that, on the third round of calls, there's going to be 1, 2, 3 2s. That 2 is used as a factor 3 times. When I look at the fifth row, 2 is used as a factor 1, 2, 3, 4, 5 times. So whatever calling round it is, it could be round number 27, and 2 would be used as a factor 27 times. So take a look and see what you think. You need to pause and fill in your answers. All right, step it out on the next page. A dot is sometimes used instead of the symbol X to represent multiplication. And that's something you guys already know. You can use an exponent and a base to show repeated multiplication of a factor. The expression shown is read as 7 to the 5th power. And here's where we start using those vocabulary words, base and exponent. So 7 is the factor, and it's repeated 1, 2, 3, 4, 5 times. So 7 is the repeated factor, 7 is the base. It's the big number, basically, when it comes to exponents. And then your exponent is that tiny little number that goes to the right, up on the right-hand corner of your base. That shows how many times the base is being multiplied times itself. So, there are two specifically named powers. 8 to the 2nd power can be read as 8 to the 2nd power or as 8 squared. Whenever you see a 2 for the exponent, it's read as squared. And then 9, with the little 3 right there, it's read as 9 to the 3rd power or 9 cubed. An exponent tells us how many times a number is used in an expression. Look at this expression. We have 5 times 5 times 5 times 5. How many times is the factor 5 used? We have 1, 2, 3, 4. So 5 is used as a factor 4 times. Complete each statement. Ooh. We have 5 times 5 times 5 times 5 equals 5 to the something or another power. So we have 1, 2, 3, 4. So it is 5 to the 4th power. Here we have 8 as our base. We have 1, 2, 3, 4, 5 8s. So that means it's going to be 8 to the 5th power because we would be multiplying 8 times itself 5 times. Question C. Write an equivalent repeated multiplication expression. So we start with 2 cubed. See how our exponent is a 3? That means we're going to multiply 2 times itself 1, 2, 3 times. The next one is 1/3 to the 5th power. So we're going to multiply 1/3 times itself 5 times, because that's what our exponent tells us to do. So we have 1/3 times 1/3 times 1/3 times 1/3 times 1/3. We have 1, 2, 3, 4, 5 1/3s. Okay, so for number 3, we have 5 cubed, which also equals 5 times 5 times 5. Well, what in the world does that equal for our whole product? 5 times 5 is 25. 25 times 5 equals 125. So we will put 125 in the blank. For 4, we have 4 to the 5th power. So that means we will multiply 4 times itself 5 times. So we have 4 times 4 times 4 times 4 times 4. That's 1, 2, 3, 4, 5. So if we have 4 times 4 times 4 times 4 times... Did I do that right? Hold on a minute. I'm actually checking my work on a calculator because I'm questioning myself. Dang, that's a big one. 1,024 is the product of that one. Okay, see, even I have to check myself sometimes. Totally normal. All right, we'll go on ahead and do the check understanding together. And let's see. So, a farming community begins with 1 resident. Then, every year, the number of residents multiplies by 10. Write an expression using an exponent to represent the number of residents in the community after 5 years. So, 10 is going to be our base. And then, because it says that the numbers multiply by 10, so it would be 10 times 10 times 10. Using an exponent, represent the number of residents in the community after 5 years. That is our little exponent. So you'd have 10 times 10 times 10 times 10 times 10. Okay? Number 2. On a tree, the trunk splits into 5 branches. Then each branch splits into 5 smaller branches, and each of those branches splits into 5 very thin branches. How many very thin branches are on the tree? So 5 is going to be our base, and it looks like 5 is being used 3 times. So we have our 5 branches that branch out into 5 times the 5 smaller branches, and each of those splits into 5 very thin branches. So we wind up with 5 to the 3rd power. On these last couple down here for question C, or 3, explain the expression 2 to the 10th power, complete the sentence. The number 2 is used as the repeated factor 10 times, because that's what our exponent says. The base of the expression is 2, because it's the repeated factor, and the exponent is 10, because that's how many times we're going to multiply 2 times itself. Okay, and here we are. Hopefully it's going to show this last little question at the bottom. It says the value of 2 to the 10th power is something or another. So we are going to have to multiply 2 times 2, 10 times 3, 4, 5, 6, 7, 8, 9, 10. Do I have it right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Kiddos, when you have exponents, it doesn't mean you multiply 2 times 10 and 2 to the 10th power is 20. It means that you have to write this out, write out 2, which is the base, write it out 10 times, because you're going to multiply 2 times itself 10 times. So we have 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 18 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, 128 times 2 is 256, 256 times 2 is, oh no, I'm totally blanking, 256 times 2, 256 times 2 is 512, and then 512 times 2 is 1024. So the value of 2 to the 10th power is 1024. That answer is very different from just 2 times 10. That is why this isn't just regular old multiplying. We have our 2 to the 10th power, and we wind up with 1024. Alright, we are going to stop here for today. Make sure you have everything in your notes, and I will be checking these at school.